Hello YouTube, my name is Johnny Bandon and I'm with Treppa Technologies. And today we're going to be going over how to configure classic mode EIGRP on Cisco routers. For this video tutorial, I'll be following Treppa Technologies' Confluence webpage for IT how-tos. So please check the description below, click that link, and follow along with me as we go through Treppa Technologies' how-to page on Confluence. Without further ado, let's start configuring. So as you can see now, we're at my GNS3 application. For this video tutorial and future ones, we'll be using GNS3 to emulate viral and 7200 series Cisco routers. The operating system I'm using is Ubuntu Focal FOSS 20.04. So if you need to get your workstation set up like mine, please visit Treppa Technologies Confluence page for how-tos or gns3.com. They have great how-tos, and that's what everyone uses to get started installing GNS3. So first things first. In this video, I will teach you how to clone a Git repo. So why, as network administrators, would we do this? Well, before we start configuring any router, we need to put a baseline in it. If you're a good network administrator, not falling behind the times, you're going to be using some form of source control management. At my company, we use GitLab. So I'm going to go to GitLab for Treppa Technologies Router Baselines project, and we're going to clone that Git repo to my local machine, create two baselines for router 1 and router 2. Then we will paste those baselines in the routers, and then push up those new baselines we created back to gitlab.com. This is just simple form of source control that every company in IT should start doing. First things first, let's go to GitLab. And if you didn't click that link, here's what you should be following along to this video. This is our Confluence page, and we have plenty of IT how-tos that you can also browse through. Let's get back on track now. So in GitLab, we're going to go to the project we want, Treppa Router Baselines. And we're going to copy this URL. Now you can do Git clones from the command line. You could actually just come down here and copy this folder, download it. But I'm going to use Visual Studio Code for everything. So in Visual Studio Code, which is a free software, a free text or IDE editor, whatever you want to call it, provided by Microsoft. So to Git clone here, we're going to hit View, and then Command Palette. We're going to hit Git clone, which is my recently used, but you can also search it there. We're going to paste that URL. Now we're going to select the repo location. I'll use my home folder. It's going to clone this Git repo, and it's going to prompt me for credentials. This is a private project that I'm trying to clone, so I need credentials. We're just going to go ahead and open this. Now in our Windows Explorer, you can see that folder. We're going to come here to this already created baseline, and we're going to create a new file from this to make our baseline for router 1 and 2. Looks like here our work's already done for us. This is router 2's baseline. So we're going to save as. We'll name this router underscore baseline, R2 underscore baseline, excuse me. We're going to save that. As you can see here, since it's a new file, it's going to come up green, which means untracked. So that means Git has no idea what's going on with this file. So we need to stage, commit, and push this file back up to GitLab. We'll do that once we create router 1's baseline. Go ahead and change that host name, change the description, change the IP address of our loopback and our physical interface. And these IPs I'm getting from our quick little network diagram we have here in GNS3. So now that we made this change, let's go ahead and save this file. We'll name this one R1_baseline. Great. Now let's go over here to our source control window pane. It tells us we have 3 pending changes. So in Git, first we want to do is stage all of our changes. We can do that hitting this button here. This can also be done from the command line. So if I open up a terminal, we can type in git commit. But we're going to do this all from Visual Studio Code. So we're going to type our git commit message here. So this message can be anything you want, but we want it to make sense. So we'll type in created R1 and R2 baseline. Then we're going to hit Control Enter. Now that we have committed those changes, we're going to go push these changes to our remote branch. This is going to put those changes onto our GitLab repo. So now that they're pushed, let's check and see if they're actually there. So we'll go into our one folder, and there we have it. 30 seconds ago, these baselines. So now for everyone in our company, we know where to go get the baselines for R1 and R2. This is what all IT and especially network engineers should be doing in their network as far as tracking all their router's configurations go. Now let's console in to our devices and paste those base configs. Expand this a little here. All right. Back to VS Code. We'll get our baseline here. Copy. Paste. We'll get router 2s. We'll copy and paste. Awesome. So now let's go back to our GNS3 network. Now we need to actually configure classic EIGRP. We're going to advertise the local connections on each router. We do that by going to global config mode on our routers and getting in to the EIGRP sub-configuration mode. So we have 2 options here. We can either do classic mode, which is just typing in an autonomous system number, or go into name mode. In this video, we're going over classic mode. So we're going to type in router, EIGRP, and autonomous system number. Now, if it's been a while since you've done any network administration, remember that this autonomous system number needs to match for all routers in your EIGRP domain. So router 2's autonomous system number will also be number 5. First command we'll do is no auto summary. This is kind of a legacy command. This prevents classful advertisements of our networks. On newer iOS's, like 15.2 and above, this shouldn't be a problem. I just do it out of habit, and so I keep doing it in case I'm on old iOS. Now we're going to use the network command to advertise our up and active networks on our router. So what do I mean by that? So I'm going to advertise Tri-Systenet 00 on router 1. We're going to use its IP address, and then a wildcard mask is 0000. And then I'm going to advertise our loopback 0 address with its network address, and then the subnet's inverse, which is our wildcard mask. So what do I mean by only up and active routes? If my loopback 0 was shut down right now, it was in a shut state, and I typed this network command in, EIGRP would not advertise that network. So be careful when typing in this network command. Know that it only will advertise up and active connections. Now let's do this configuration on router 2, and we'll do it a little faster. And again, I'm using the tab completion to make it a little quicker to finish these commands. And as you can see from that syslog message, we have EIGRP neighborship, new adjacency. So that is it for classic mode EIGRP configuration. It's that easy, it's that simple. Now let's get into some verification. I will only go over 3 verification commands. These are just the basic commands we need to get into verifying and troubleshooting EIGRP. So from this global subconfiguration mode, you can actually do show commands by putting the do keyword in front of it. So I'll type in do show IP EIGRP neighbors. A couple key things to note here. First thing I want to show you is this queue count. What does this mean and why is it important? This queue count should always be at 0. This queue count means that this network is fully converged. 0 queue count equals fully converged. If it is anything but 0, that means we have a problem in our routing, a problem with our neighbors advertising routes, and that we are not in a fully converged network. Other key thing is our hold timer right there, our interface, and then our neighbor's IP address. Then this is showing us that this is our first neighbor. We know in technology 0 means first, right? So now let's go to our second verification command. I'm going to type in end here. And now let's look at our EIGRP topology. And not only do we want to see the feasible, we also want to see the non-feasible successors. So that's keyword all links will show us the entire topology, even the routes that don't meet EIGRP's feasibility condition. And again, if I'm speaking Latin or some weird language to you, go ahead and click that link below. Go to the Confluence webpage by Trevor Technologies, and a deep dive into EIGRP for you. If some of these terms are a little foreign, if you're just refreshing. Because we know in EIGRP, to become a successor or a feasible successor, we must reach the feasibility condition. Well, that doesn't mean that non-successor routes do not get advertised to our neighbors. This router knows about those, but if we were to type in show IP EIGRP topology, it wouldn't show us those non-successor routes. In a small network like this, it doesn't really matter. But in a large network, we want to be able to see everything in our topology, and we mean everything. So don't forget this keyword to see even non-successor routes. The last verification command we'll do is show IP route EIGRP. This will show us our routing table, and it will only show us EIGRP learned routes. Here, you can see what network's being advertised. It's classless, not classful. It's being advertised via our neighbor. Here we have the administrative distance of 90. That's EIGRP's AV. And then we have the metric. And we know this is an EIGRP route, not just because we typed in, but also because this code right here, which represents EIGRP. All right, pretty easy, classic EIGRP for Cisco. Really not much to it to get it started. However, there is a lot of different configuration you can do. And in future videos, we'll get into name mode and some of those other configuration options for EIGRP. So from everyone here at Trepid Technologies, thank you for viewing, and remember to keep learning every day. Thank you.